I wanted to illustrate where we stand in terms of model development. So we've got one question, are they scientifically correct? But then, how far can determinism go in dealing with the real world? And this is where I'm going to get on to standards in a moment. There needs to be more, in my view, more concentration on probabilistic methods. We need to get the physics and the chemistry right for the deterministic model, but we also need a probabilistic end. And I decided to pinch here a slide from Ku, who's at the University of Edinburgh, application of the CRISP model to the FIREGRID project. It's a rather different kind of project, but it illustrates the use of, this is a zone model being used, where they've pre-calculated essentially what possible options might be, and they've allowed the model to be steered by measurements actually occurring during the development of the model. So it's not something you could do in design, but it does point the way to how these kinds of models can be used and should be developed, it seems to me. Okay, now we're getting on to testing and standards. Philip Thomas, as I pointed out earlier, was the chairman of TC92 ISO, International Organisation for Standardisation, as it should be said in English, for 20 years or so, and during that period fire safety engineering developed apace. The scientific community had been concerned with the testing methodologies that were available and still are available. And this is a quote I know that Professor Drysdale likes to use, that when Professor Kawagoe from Japan was on a sabbatical at the Fire Research Station in the early 1960s, he was asked what was the purpose of the research that he was doing. And he said then it was to do away with the fire resistance test. Okay, you don't need to read that. But this is, I'm coming back to Philip's contribution here. Philip, as I pointed out, was coordinator, Philip Thomas, of CIVW14. And as a result of the scientific progress that's been made in the field of modelling fires, not CFD, but modelling more generally, including physical modelling, it was felt that the standards generating bodies should be meeting the challenge. In other words, the tests that were then available were not producing the information that was really required in support of fire engineering. So he wrote to the Secretary General of ISO, and the consequences were that a subcommittee of TC92 was established to develop fire safety engineering, and the outcome of that, which was very successful, and this is when I took over TC92, was that the title of ISO TC92 was changed in a very dramatic way, really. It had been called Fire Tests on Building Materials, Components and Structures. So it was buildings and it was tests. It was then changed in 1995 to fire safety. So that encompasses all sorts of structure, and it doesn't just mean tests, it means engineering methodologies as well. So this was a substantial change in its remit, and it ruffled up a lot of feathers, because it wasn't the only committee that thought it knew about fires. Many of the specialist committees, say on ship fires, thought they knew about fires, and so it caused a bit of friction, and that's something I had to deal with, which I inherited from Philip. TC92 set about looking at what it should do next. How should it meet this challenge? And it came to the conclusion that we need new tests, where the product performance in the test is provided in quantitative terms. Exposure conditions must be provided in quantitative terms. We don't just want past fire. The processes in the test are sufficiently well prescribed that they can be modelled. They don't have to be modelled with theoretical models, they can be modelled with physical models, but they need to be modelled. And that the performance from the particular conditions of the test can then be translatable into real-world behaviour, if you know what it is. And there's this rather complicated schematic that tries to describe that process. The squiggly area at the top is meant to be the testing environment, and the one at the bottom is the real world, which are linked via some kind of modelling capability. Now, that's all very well, but again, not only do fires exist in the real world, but we have to exist with politicians and other influences which affect the real world, and they affect our progress. The European Commission, the European Union, adopted a test that did not support this kind of thinking. It was partially understandable in a way, I think, because they had to do things urgently. They required to introduce a test that could be used and accepted by all countries, member bodies in the European Union. But there were hails of derision when this test was announced from the scientific community. The other unfortunate development was the privatisation of many of the national labs. My own lab included, but many in Europe and Australia and so on. It was a fashion at the time, which maybe now that the financial world is beginning to fall apart, maybe they'll think again about it. And there was a lack of strategic research.